Lecture 16, properties of the Lie bracket. Again, I would like to emphasize, to remark that these are all tools that will be important when I will derive curvature. You see, I'm preparing you from these tools, okay, covariant derivative, Lie bracket, just to use when I will talk about curvature. But this Lie bracket I already derived, okay, in previous lectures. Okay, so definition, you see, Lie bracket is x acting on y minus y acting on x. You see, here are the properties. Okay, so xy is antisymmetric. This is antisymmetric. Say antisymmetric. Now property 2, x plus y comma z, xz plus yz. You can use this, you can show this using local coordinates. It's quite easy. Now the third one, you see the Lie bracket here inside, comma z, that's the Lie bracket. You see, you can cyclically, you can cycle. You see, you have x here, y here, z here, x here. Again, y here, z, x and y. This is the Jacobi identity, which I already derived previously. You see? Now the number 4, you keep the Lie bracket of fx, plus, in this case, comma gy, f and g, they are functions, okay, scalar. Then I can express of f, this case, xg, y minus gyf, x plus fg, x and y. Now, I recommend you, okay, to repeat my derivation, just setting here w and setting here z. And you apply the Lie bracket here, and you see clearly why it appears this term over there, fg, Lie bracket of x and y. You see, that's an easy derivation. Number 5 is xy, the Lie bracket at point P. You see, this is local coordinates. xp, yf minus yp, xf. You see, all these, we use the linearity from linear algebra. You see, the linearity says that x applied to the sum here, f adding to g, okay, just expand xf plus xg. This is a characteristic of linearity. Also another one, x applied to alpha, f, alpha is a number, okay? So this is alpha, x applied to f. Is another characteristic of linearity. And also Leibniz rule, product rule, okay? X, f, g, okay? You just use the product rule here, sfg plus fxg. Now, I will show a very interesting, okay, relation just using this property 4 over here. Okay, I'll derive in local coordinates on the chart uxi, and I would like for you to remember that xi, they are labels, okay? They are labels. Now, to use relation 4, okay, relation 4 over here, so x, this is the components, okay, contravariant components which belong to the vector space, okay, partial xi and yj partial as xj. So I will substitute this here right over here, okay, using this minus sign here from the definition of the Lie bracket. So I can here expand, okay, this derivative. You see the blue one, okay, I write the blue one over here and I expand. See that I use the product rule, the Leibniz rule. You see, this is the expansion here. Again, the green one, you see the green one, okay, I just write here and expand using the Leibniz rule. I here equation 1, 2, and 3. Now, because I'm applying the Lie bracket, there is a minus sign over here. So I subtract, okay, in this case, okay, 2 minus 3, 2 minus 3, and I substitute it 1, quite clear. And remember that, you see, xi multiply yj minus yj multiply xi. So this is, I assume that f is a smooth function. So I can swap the derivative over here and cancel, you see. Now, then I repeat property 4, xy applied to f. I just write over here because I already cancelled, okay? This I multiply xi by xj minus yj xi, and I subtract. So this leads to this just expression over here. Now you see, look, I is dummy. In this case, jj is dummy. I can substitute I by jj and j by I. No problem, because it's a dummy indices, okay? Now I substitute. This I have partial f with respect to xi. Not over here, partial f with respect to xi. I can group, you see? So this is the difference. This is partial f with respect to xi. Now, I want to move, okay, f and f, okay? Then I repeat all this, okay, not writing f, you see, not writing f, you see? So this, the final is partial xi, you see, there is no f over here. So this is an important relation, okay? Now the particular case, okay, in which xi is equal 1, yj is equal 1, you see, this is be partial of 1, it will be 0. This is partial of 1, this will be 0. Then, in this case, okay, this is 1, this is 1. So, in this case, the Lie bracket of the basis, okay, partial xi, partial xj is equal to 0. There's a very important relation when you talk about curvature. That's important. That's it.